This is the Biomass Pelletizer Senior Design Project, a part of North Dakota State University. This project was mentored by Dr. Zhangfa Wu and sponsored by the NDSU Mechanical Engineering Department. The members of this group included Ivan Vazquez, Jake Freitag, Chase Tozer, and Andrew Kolling. When it comes to pelletizing, a material must first be ground down to a fine dust using either a chipper or shredder. Once this is complete, the shredded biomass moves to the next stage and is ran through a pellet mill, where pellets are formed from pressured-induced extrusion. The problem with this whole process is that it is actually two separate processes, shredding and pelletizing. The main objective of this project is to take the shredding or chipping process and combine it with the pelletizing process to ultimately make a portable, self-sustaining, and cost-effective integration of the two. With the objective and constraints understood, design began with multiple concepts of each process being drawn out and evaluated. With the concepts selected, CAD design began on the pelletizer and chipper. This was quickly followed by FEA analysis on both the chipper and engine stand, being that they will be the ones experiencing the most stress in operation. Once the design was deemed saved, a final CAD model could be assembled. Upon completion of the design, the manufacturing process began with fabricating the chipper, enclosure, and stand. After a lot of welding, grinding, and plasma cutting, the chipper started to take form. Now with the chipper built, the manufacturing of the pelletizer could commence. This consisted of cutting aluminum tubing to house the pelletizer, fabricating our own drive shaft to transfer power to the pelletizer, and cutting out a pellet catcher to catch the pellets as they fall from the extruder. With the pelletizer complete, the final prototype was assembled and prepped for testing. Starting with the chipper, we first tested how a piece of styrofoam would hold up. It performed as expected. The final chipper test was conducted with a piece of wood. This would allow us to see just how well our chipper was at shredding organic material. The chipper wasn't able to produce a fine dust from wood as planned, but we were able to make some pretty fine chips. With the chipper testing complete, the pelletizer was up next. We first tested the pelletizer just by starting it up and looking for any signs of instability. None were found, so the next test could begin. When pelletizing, a binding agent is used to allow the biomass to stick together and form a pellet. For the purpose of this test, no binding agent was used so that it could be compared to later tests as a control. As expected, no binding agent made it hard for the sawdust to stick together and no pellets were formed. The final test involved adding a binding agent to the sawdust and running it through the pelletizer. The pelletizer was successfully able to form pellets at a decent rate. With no catastrophic failure occurring during testing, we have deemed our project a success.